Thanks, Hyun. Thanks, Tony, for sorting that out. Thanks to everyone again. I'd like to echo what Tony, what Hyun said, and thanks for coming along and listening. So I'm going to talk a little bit about Amino Network and how it works as an intelligent, decentralized, distributed computing platform. And so in order to do that, I'm going to first talk about what each of those terms mean. And so for the intelligent part of Amino, this means that Amino is able to sense what's going on. It means Amino is able to use that information about what's happening to then predict what's likely to happen next. And then once it knows what it thinks is going to happen next, it's going to adapt its behavior and in the short term, and also look to evolve the system itself in the long term. And I'll explain all of that later on in the talk. It's also decentralized, so one of the keys of blockchain in particular is that there's a peer-to-peer architecture. And so in the peer-to-peer architecture, we have the consumers of the Amino resources talk directly to the master nodes, and we'll talk about those again shortly, and communicate their tasks, and then the master nodes disseminate those to slave nodes that then come back through the results come back to the consumer via the master node. So there's a peer-to-peer architecture between the middle layer of Amino and consumers. There's no central control or governance of the system, so it's all completely decentralized through one of the tokens, and so that means that everyone who owns one of these governance tokens gets to vote in terms of how the blockchain is processed. However, we do have a common system, and that's provided to us via Amino OS, and also the common blockchain ledger that is maintained by the supernodes, which again are voted on by this decentralized governance structure. So that's what I mean by that Amino network is decentralized. It is also distributed. What I mean by distributed is it's the implementation of Amino, the functionality of Amino is provided by thousands of computers all working together. So we have different components of these computers in different locations, but they're all working together to provide this functionality for all kinds of different computing jobs. So that's where the computing comes in. And so some examples of computing tasks that I think are particularly useful for Amino will be things like CG rendering, particularly machine learning, ideas of simulation and even optimization, which is so simulation, optimization, and machine learning are fundamentals of artificial intelligence. So this is how Amino is intelligent, decentralized, distributed computing platform. And now I'm going to talk a little bit about why we've come up with Amino, and then I'll talk more about how these things provide the benefits of Amino. So as Hyun said, the world needs better cloud computing infrastructure, and that's because currently it's quite high cost because all the cloud compute providers have big data centers they have to run, whereas Amino is going to reduce the cost because we're going to increase the supply of compute resources by allowing everyone to use their idle compute power to provide those compute resources, and we're going to spread that cost amongst all of the people providing those resources. Again, as Hyun said, current cloud resources can be high latency unless you have a data center sitting right near to you, and Amino is going to reduce latency because you'll have slave nodes spread throughout the world, and so you'll be able to talk to one of the slave nodes that's closer to you rather than having to send your compute task all the way to a data center and then back again. Current cloud have limited scalability, even though I'm sure some of you and I have seen pictures of enormous data centers with warehouses of computers. That doesn't equate to the power of if everyone took their idle compute power, as Hyun said, 19 hours of compute just sitting there at home, and we put all of that to use. So Amino is going to get past this idea of limited scalability, having to build these big data centers by providing this large-scale distributed compute resource. Network congestion is another issue that's going to get more and more prevalent with 5G coming in. All of our cars driving themselves around, sending information across the network, and Amino solves that problem too, because rather than sending the data from your car or your home across the network to a server and then get it all the way back, it'll send it to the nearest Amino slave node, which hopefully will be, might even be your own computer, but hopefully be a couple of streets or a suburb away. And the last issue is information security, and that's about with cloud, all the information is stored in a few different places, and even though those places are secure, if one of those places is compromised, then potentially that whole area or the data in that area will go off the grid. For an example was when one of the Amazon data centers went down, I think it was around Washington DC, and the whole area was sort of brought down to a crawl. And Amino improved security, one by distributing it, but also by ring fencing the compute resources. And I'll talk about this shortly with Amino OS, is that where the Amino compute is provided from is essentially a separate machine from the user's machine, and so the Amino OS allows us to provide this really unique separation of these two machines, and so then you sort of ring fence the virtual machine that's providing the compute resource. So Amino has really separated out the compute resource from someone else, from the computer that it's, or from the operating system of the owner of the computer that it's running. So this is how Amino provides a better cloud computing resource, but also Amino provides a better decentralized environment for computing, and again I'll talk about some of the reasons why. So one of the first ones is, even though blockchain apps use decentralized ledgers, they're often relying on centralized servers to provide the actual functionality of the apps, and the mining of those ledgers is centralized. Amino is completely decentralized. It not only has the decentralized blockchain ledger, but the compute environment is completely decentralized, so it's sitting on people's computers at home. Under some of the current decentralized computing models, both the providers and the consumers are unhappy, and this is for the reasons that Haiyan talked about before with Alice and Bob. So if Alice is providing a resource and it fails before the compute completes, then she doesn't get credit for completing that compute, even though her computer was working on it for quite a long time. And I was talking with one of the other founders, Felix, about this. It's almost like if an Uber driver picked you up and drove you almost all the way to your destination, but they ran into a traffic jam, so you hopped out of your car and walked the one block, and you didn't pay them anything. So it's not really fair to provide a resource, and just because you didn't complete 100% of the job, that the time effort that your resource provided isn't compensated for. But then on the flip side of the coin is, if the consumer is using the resource and it fails, then they have to then go back and ask for it again and again and again until the contract is valid, or they get sick and they give up. And so they're not really happy with this situation either. And so what Amino does is it provides a fairer way to keep both consumers and providers happy, because providers are compensated only for the time and availability and usefulness of their resource. And I'll talk about that a little bit more shortly. And so it doesn't matter how many jobs they complete, it's just about them having a good resource available for Amino to utilize. And what that means is we're going to have a lot of resources available, and so because we've got a much larger, distributed, large-scale environment, then for the consumers, we won't just start their job on one slave node, we might start it on 2, 3, depends how many slave nodes we've got, so we might start their task concurrently, and then the first one finished will provide that back to the consumer, and so we have a much higher likelihood of tasks being performed in a timely manner using the Amino system. Okay, so we need Amino because it provides a better cloud computing infrastructure, and because it provides a better decentralized environment for computing. And now I'm going to talk a little bit about, I'm going to work my way backwards now, so I'm going to go computing, distributed, decentralized, intelligent, and talk about each one of those components help provide these solutions that I've just talked about. So the first one is the computing resource, and really the key to Amino is it's unique. It's not really an operating system, it's actually a hypervisor. So Amino OS is a hypervisor that you can use on your personal computer, and what that means is that you can create 2 virtual machines. You can have your owner's virtual machines. This would be maybe my Windows or a gaming machine. If I'm a Linux junkie, this might be Ubuntu or Debian or CentOS. And then also beside this, basically almost unknown to the user, except that they bought the machine, is the Amino slave node. And so because these are 2 virtual machines, are effectively separate, and the hypervisor organizes that when the owner's using their machine, it's using the resources of the workstation. When they're not using their machine, then they'll either shut it down or put it into sleep mode, then the slave node can take over, it can let Amino Network know, hey, I'm ready, I'm here, I can do some compute for you, and you can start generating gas to the owner. Okay. And the nice thing about this is that it comes completely pre-configured. So there's a few different distributed computing platforms where you can donate your computer to the network. One of them is called Folding at Home for protein folding. Another one is called SETI, which is the Search for Extraterrestrial Life. And in both of those, you have to load up a system and get your computer on the network, and there's quite a high barrier for contributing your computer into the system. With Amino, it's easy. You just buy your computer, it becomes pre-installed with the Amino Hypervisor and with your the slave node in there, and also with whatever OS you decided you want on your machine at home. So you have your Windows OS set up there, you have the slave node OS set up there, and it's all sitting on the Amino OS, and you just go and plug it in and use it like a normal computer, and every time you shut it down, it's generating tokens for you. The nice thing also, as I said, it's sort of ring-fenced. Put your hand up if you know what ring-fenced means. Okay, it might be a New Zealand term. What that means is effectively isolated. So we talk about in networking system and distributed networking, you talk about ring-fencing stuff. So that means you're basically closing off from everywhere else. So the compute resource is closed off because while the owner of the machine will have, they can control their VM, the Amino VM is sitting there, and they don't have control over that VM at all. And so what it means is this is a compute resource that won't touch their virtual machine, and they won't be able to touch that. As I said, there's no barrier to entry. You get the workstation, get everything installed. But the nice thing is now, the beautiful thing about the Amino slave node VMs is that means that every single computer, no matter what computer you bought, no matter what operating system you want to run personally at home, it's going to have the same environment ready there to be a slave node. So Amino has access to thousands of machines that to it look exactly the same, except for potentially the hardware that they have access to. So that's how Amino does the computing side of things. In terms of the distributing side of things, Amino has 3 tiers. So you saw in Hayon's slides, and I'll show you again. You have the super nodes, the master nodes, and the slave nodes. So the slave nodes, which do all the compute, are managed by the master nodes. The master nodes are managed by the super nodes. The super nodes control the blockchain, so they receive contracts which go into the block for task execution from the consumers. The super nodes then decide which one of the master nodes should be makes the best peer-to-peer interface for the consumer. And the way they select the best master node is one of the things we talked about was congestion and latency of the network. So they will look at the proximity of the consumer to the master node, and that will make all the communication of that task execution straightforward. They will also look at available compute resources, or how many slave nodes does that master node currently have, how many of those slave nodes are being used. So how busy is that master node? And it might be the best thing for you to do is not to go to the master node that's next door to you, but the one that's across the street, because it has freer resources and you can use those resources. And so then the master nodes receive the tasks from consumers. So the super node will choose a master node. The consumer will then interface directly in a peer-to-peer manner with that master node. The master node will then have a look at its slave nodes and decide, hey, this task is going to go to the slave node. The task will get completed, come back to the master node, it'll go back to the consumer, the task is done, and then there'll be the contract will be complete on the blockchain and move through. So the master nodes also do some selection, so they select which slave nodes are the best ones, and there's 2 things they'll consider here. One is the slave node fit for purpose for the task it's allocated, or the task it needs to do. So an example would be a high-end gaming machine will have a good GPU. GPUs are really good at linear algebra, so if we have a machine learning task that requires a lot of linear algebra, we might say, hey, I know this one's got lots of GPU, this one's got lots of CPU, I'll use this one for my machine learning task because I know that GPU is going to perform that task better than a high CPU node. So the master node will select the fit for purpose slave nodes, and also again, if it's sending everything to this slave node that's becoming overutilized, then it might start sending some to the other one to balance the load across the slave nodes. So the super nodes will balance their load across the master nodes, and the master nodes will balance their load across the slave nodes, as well as taking into account the compute resources available, and for the master nodes, the proximity to the consumer. So that's how Amino distributes its tasks. And then Amino is also decentralized, and the key for the decentralization are two things. One is that there's a decentralized governance or control of the blockchain, and so that's one of the beauties of blockchain, is that it takes the risk out of the contract, so they manage all the contracts automatically. And then the second way is that the master nodes provide this peer-to-peer connection to the consumer. So you don't have to send your job through some central big server anywhere, you just connect to your local master node and communicate all the information back and forth to that local master node. The slave nodes again provide the compute resources, and in return for the compute resources, the providers of those slave nodes get gas. And in terms of when a consumer contacts a master node and wants to use a resource, then they get charged gas. So we have this utility token moving around the network, moving through the Amino network, which rewards providing resources and charges for consuming resources. And then the AMO, which is the second token, is the governance token, and the AMO token works in the following way. Everyone who has AMO tokens gets to vote, and they get to then vote on which nodes they think should be the super nodes, and so this is the idea of a delegated proof of stake. So the AMO is the proof of stake, and the delegation then is the vote to decide which ones are the super nodes which are maintaining our blockchain, which does all the contract. And I could talk at some depth about this ecosystem, but just watch this space because we have a white paper coming out that you guys will want to get home sometime tonight, so maybe I'll leave it for the white paper. So then in terms of efficiently providing resources in the near future. So the Amino network is going to be sensory, so there'll be monitors to look at the slave node performance, but not just their performance in general, their performance on various tasks. So I talked before about rendering or machine learning or simulation. So each of these are different types of tasks that require different compute resources. So some of the slave nodes may do better on the machine learning tasks than on the rendering tasks, and Amino will check to see how well slave nodes are performing on various tasks. It'll also monitor the profile of tasks being requested, and this may be geographic, maybe time dependent. All of these factors can be taken into account. So it might be that Shanghai likes to do lots of machine learning, but Hangzhou likes to do lots of rendering, and so we're going to, if a slave node is good at machine learning, then we like it more in Shanghai, and if it's good at rendering, we like it more in Hangzhou. So this profile of tasks is going to be monitored also. So we're measuring what tasks are coming in and where they're coming in. We're monitoring how well our compute nodes, our slave nodes do on those tasks, and we're also going to look at network performance. So it doesn't matter how well my slave node does on a task, if my master node can't send a message to it in some reasonable amount of time, then it's going to be no use to me. So we're also going to be looking at the network performance. In other words, if the master node tells the slave node, hey, do this job, how long till the slave node said, yes, I've got the job, I'm going ahead with it. So we're going to know what's going on throughout the Amino network. We're then going to use our own machine learning predictive algorithms to see, given that we know what tasks are coming in, which task do we think is going to be next, and where do we think it's going to come from next? And then, given that we now know, we now estimate which tasks are coming next and where they're coming, we're going to then estimate, well, how long do we think the slave nodes in that area are going to take on that task, and then we're going to reward the slave nodes that do well on the tasks that we need them to work on are going to be rewarded more gas. Okay. So we're going to see what's happening, we're going to predict what's happening next, and then we're going to adapt how Amino works to make sure it rewards the slave nodes that perform well on the tasks that we're seeing a lot. So that means the resources that are really useful to us are being rewarded more gas. As well as rewarding more gas to our valuable slave nodes, we're also going to make sure we have lots of nice optimization algorithms, which is one of my expertise, to make sure that when we allocate tasks to the master nodes, that's done in the most efficient way, using both current workload but also predicted workload. And when we allocate tasks to the slave nodes from the master nodes, that's also going to look at both what they're doing currently and what we predict they're going to need to do next. So Amino is not only going to sense what's going on, predict what's going to happen next, it's then going to adapt its behaviour to work most efficiently on what's coming up next. And the last thing, which is a longer term adaptation of Amino Network, which I call evolution, is the idea of, so the example I said before, if Shanghai is doing a lot of machine learning and there's not very many machine learning, not many slave nodes in Shanghai that are good at machine learning, then I'm going to start wanting to pay gas for slave nodes in Shanghai that are good at machine learning. So all of a sudden someone's going to say, hey, I can get a lot of gas if I buy this type of node here. And so all of a sudden, once Amino will adapt what's available in the infrastructure by incentivizing it with gas to make sure that it has the best possible infrastructure for the workload in each area. So by monitoring what's going on, by incentivizing the contributors of the resource appropriately, then Amino not only adapts day to day, but evolves long term to best fit the compute tasks in each area. Okay. So those are the ways that Amino is intelligent, Amino is decentralized, Amino is distributed and providing a computing resource. So let's quickly go back and have a look at the solutions around why Amino is a better cloud computing infrastructure. And as I said, Amino is going to reduce the cost of cloud compute by enabling anyone with an idle computer to contribute. So you don't need to own a data center to contribute cloud compute resources, you just need to have a computer with Amino OS on it. It's going to reduce the latency by increasing the number of compute nodes near you. So we're going to increase the density of compute resources. Again, hopefully even your own PC might be doing some of your compute, or maybe your neighbours across the road. We're going to provide large-scale distributed compute because there's now no barrier to entry, and we have a common compute node, so the distribution across all our slave nodes is relatively straightforward, and so now we're going to get a distributed system with potentially thousands of nodes in it. So we've solved scalability. We're going to reduce congestion because, like I said, your compute resource hopefully is just across the street, so you're not going to be moving all your data across lots of hops of your network. You're just going to go 1, 2 there and then back again. And we're going to improve security because the two virtual machines, the virtual machine of the person who owns the Amino hardware or the Amino box at home, theirs is completely separate inside the Amino OS from our slave node. So these two machines are existing effectively in isolation from one another. And then the other thing I said that Amino is going to do is provide a better decentralized environment for computing. So the Amino ledger is decentralized as are many other ledgers, but the compute environment is completely decentralized. So Amino is not depending on big centralized servers to provide not only the distributed app, but the mining of the ledger. Amino compensates you for the time your resource is available. You don't have to compute tasks, you just have to have the resource available and you'll be compensated for it. And then because Amino will have lots of slave nodes available, properly compensated, then when a consumer asks for a task to be done, it will be performed in multiple places concurrently, so you get better reliability in terms of the performance of your task. And so that means it's much less likely that your task won't be performed the first time out. So I think with all this great combination of intelligence, decentralization, distribution, and thousands of compute resources, Amino is perfectly positioned to be the next generation decentralized computing network.
So, is there any question or something that was not clear? Maybe it would be the occasion to ask. Please.
Yeah, in terms of the master nodes, super nodes, it reminds me the Kubernetes.
Yeah, Kubernetes. Yeah.
But actually, I think as a practitioner doing the machine learning, I think the task differs. For some tasks, actually the CPU is lightweight. I only use 3 or 4% of the CPU, but it consumes a large amount of memory.
Yep.
Like AdaBoost, this kind of machine learning. But for another task like deep learning, actually, the size of the data is huge, like 3 terabytes and 4 terabytes. Yeah, I think for decentralized, it's good, but actually for centralized computation, it is, I can alwads get resources needed. Like I can get to 3 terabytes in several minutes, But for decentralized, do you think it is available? Because it's but that means slave nodes should be spread to this slave nodes in charge of irresponsible for the memory for the storage. Because another one have powerful CPU but less storage. So
yeah. So
with each other?
yeah. So I think I get what you're asking. So the answer to the question is it depends on the compute task you're trying to perform. So, for instance, my dad actually does geothermal well modeling, and for him, Amino probably wouldn't necessarily be the right place because he can't really decompose his problem into pieces. But machine learning, you can. So, if you're doing a neural network, for instance, there's a whole bunch of nodes in the neural network, and sure, you're passing information from one to the other, but essentially the computation can be split. And I'd say that's also the same for rendering, simulation. A lot of the simulation work I do, I can pass an entity from one component to the other, and so it doesn't need to be tightly coupled. So if you don't need your memory to be tightly coupled, then I think you can distribute it nicely through the Amino network. And I think your comment on whether you need lots of CPU and memory kind of gets back to the idea of depends what resource you're providing. So if you're providing a resource with lots of CPU and low memory, then you may not get used that much, and so that means the amount of gas you're going to get paid for being available is going to drop down. And so I think the way that Amino works is going to incentivize kind of the right machines at the right time, and that is allowed to change also. Does that answer your question? Yeah. I mean, so yeah, there's definitely some compute loads that are high performance computing loads, and Amino's not doing that. Amino's more suitable for things like machine learning where you can distribute it, like.
Do you think it would change the pattern of the coding and the programming?
Maybe, yeah. I mean, task-based computing is a pretty big deal these days. So a lot of the stuff I do with optimization and simulation, if I knew I had the Amino resource, I might write it in a different way. And I think part of it's dealing with legacy code bases and transferring how they work. But a lot of the machine learning is pretty new. So I think, they've been thinking about parallelization for quite a long time. And there's nothing in the memory that means it has to be coupled. So I think, I can see for machine learning, you basically replace your parallel virtual machine with Amino and away you go.
Amino reminds me of amino acid.
Yeah.
Because you mentioned about prediction evolving,
yep.
It's just like biological evolving.
Yep.
So it's have capability of self-learning, self-improving, right?
Yeah.
It's based on the data. The data is not obviously quite clear or based on subjection or biases. So how do you make your data more accurate for your assessment, prediction, evolving, and something like this?
So I think that's a really good question. I don't think you can get super concise on it, super accurate on the data, but I think you can look and see the performance of your slave node. So it might be this slave node with this exact type of task, that's exactly this amount of time. It'll be the performance that this slave node gets through this many machine learning tasks, generally in an hour, a day, or a week, or something like that. So I don't think you're going to go for the super accurate learning of the data, but I think you're going to get enough that the network's going to evolve, because there's always going to be uncertainty and it's always going to be changing. So we can spend a lot of time and effort trying to get those predictions as super accurate as possible and kill our performance by doing that, rather than getting a reasonably accurate estimate of those things and evolving along with that. So a lot of the stuff I do is about that prediction. And there's always the question of how much effort do we put into that prediction and how much effort do we put into making good decisions, given that we know that prediction isn't super accurate. Yeah, and so I think that's how we'll get around it. I think we'll look at the optimization algorithm. We'll realise that this is a prediction, but there's some uncertainty. And I don't think you can get that data super well modeled because you're not allowed, you know, this is people's data they're sending out, you know, you don't want to sniff the data too much because otherwise people aren't going to use the network because they're going to be worried you're watching.